Imagine if everything you know about space-time is just an illusion. What if the fabric of the universe is made up of vibrations, like an immense symphony of interacting waves? Today, let's uncover how frequency wave theory could change everything we know about space, time, and even matter itself. According to frequency wave theory, space-time is composed of discrete frequency units, or DFUs. These DFUs are like the pixels of space-time vibrating at distinct frequencies. They interact with each other through resonance, and it's these interactions that define the shape and behavior of the universe. Every phenomenon we observe, gravity, electromagnetism, and even the flow of time, may emerge from these oscillating units. But how do these tiny, vibrating points lead to the reality we see? Let's start by zooming in, smaller and smaller, until we reach the Planck scale. Beyond this limit, conventional physics says space-time loses meaning. But in frequency wave theory, it's here that we find the resonant boundary. The point where wave frequencies become so intense that they shatter the fabric of space-time itself. Think of the Planck length as the ultimate vibration threshold, where space-time dissolves into a storm of destructive interference, breaking down into quantized frequency units. It's a hidden structure, beyond which reality itself fractures into pure waves. Could it be that what we call singularities in black holes are just regions where this frequency lattice collapses under extreme conditions? Next, let's talk about measurement. In classical physics, we can measure the position or speed of an object. But in the quantum world, the very act of measuring disrupts the system. In frequency wave theory, this disruption is seen as wave interference. Each time we measure, we're adding new frequencies to the system, creating interference ripples that change the state of the DFU lattice. It's like trying to touch a still pond. Any contact creates ripples that spread outward, distorting the reflection. This means that all physical properties, position, momentum, even time, are not inherent attributes, but emergent properties of the wave lattice, depending on the phase and frequency state of the surrounding units. And what about the storage of information? Imagine trying to cram as much information as possible into a tiny region of space. The more data you pack, the denser the frequency lattice becomes. When the wave density exceeds a critical threshold, the system collapses, forming a black hole. But frequency wave theory suggests that a black hole is not just a gravitational sink, but Here, all information is stored as encoded on its surface, each node vibrating at its maximum frequency. This aligns perfectly with the which states that everything inside a black hole is encoded on its surface. From this view, black holes are no longer mysteries. They're where the fabric of space-time has been pushed to its absolute limits. What does this mean for our understanding of reality? Frequency wave theory proposes that space-time, matter, and information are all emergent properties of a deeper wave-based structure. Gravity, electromagnetism, and even nuclear forces, everything is just a manifestation of complex. Space-time itself is shaped by the interactions of vibrating units. This framework could unify the deepest puzzles of physics, from quantum mechanics to general relativity, and even the mysteries of dark matter and dark energy. We may be on the verge of a paradigm shift where the true nature of reality is revealed to be a symphony of interacting waves. Perhaps the universe isn't just a space of particles and fields, it's a grand waiting to be understood.